Okay, it's 5:25 now, or 4:25, or 1:25, whatever time zone you are in. So I am going to start this session. My name is Harry Forbes. I am an analyst with ARC Advisory Group and glad to be here. We have a very interesting group here to discuss an introduction to Project Eve and bridging to Kubernetes. I'd like to start by letting everyone introduce themselves and kind of what they do and what their background is very briefly, and then we can kind of proceed with the questions and discussion. If you have some questions you would like to ask from the audience, please feel free to put them in chat and we'll try to respond to them. I am an analyst with ARC Advisory Group. We are a small but global boutique analyst firm. We focus on industrial manufacturing and infrastructure in smart cities. We do market research, we do events, we do advisory services to manufacturing end users, and we also do consulting engagements. And we're about 90 professionals worldwide, equally divided between the Americas, Europe, and Asia. So now our very interesting panel, maybe we'll start with Roman. Would you like to introduce yourself and explain what you do?
Absolutely. My name is Roman. I do a lot of open source. I mean, that's what I do. But I also happen to be one of the co-founders of ZEDEDA. And at ZEDEDA, as some of you may know, we have a Project Eve, that's been donated to Linux Foundation's Edge. And I'm mainly responsible for running it as an open source project and also contributing, to it hands-on. I also do a lot of, related Linux Foundation projects, Kubernetes, Cloud Foundry, involved in Apache Software Foundation as well. So, like I said, do a lot of open source.
Okay, Malini, would you like to go next?
Hi, everyone. I'm Malini Bandaru from VMware, also very involved in open source. I lead IoT and Edge open source related efforts at VMware. And I've been contributing to EdgeX Foundry, another LF-Edge project.
Okay. Sebastian?
Yeah, I'm Sebastian. I'm one of the co-founders of Kubernetes. We are a European-based startup, fully concentrating on Kubernetes. We are also one of the top committers to the Kubernetes project. I think currently in the last 12 months, we were number 6, something around that. And yeah, we're building a platform how to manage Kubernetes cluster from the cloud to the core data center up to the edge, so that you are able to manage hundreds, thousands, or 10,000 of Kubernetes cluster in a scalable way.
Okay, and finally, Brad, can you introduce yourself, please?
Sure thing. I'm the mystery.
Yeah,
here with the video. So Brad Corey, Corporation and our Internet of Things group run a strategic architecture team, but we focus on bringing those technologies that are just over the horizon to scale, right? So kind of somewhere between labs and off-the-shelf solutions, trying to bridge that gap. And we do a lot of open source investments, a lot of focus on the edge. So, Alani, good to see you. Our EdgeX team being represented here, and the rest of our LF Edge folks. So happy to be here.
Okay, well, let me throw open a question here, and the topic is an introduction to Project Eve, and I want to get to that, and we'll have time to cover that. But I talk with a lot of end users in the manufacturing space. I'm sure there are other end users in other industries as well who are a little bit confused or mixed up by the multiplicity of projects. If you look at what is on the edge and the open source for the edge, you have any number of hypervisors, you have any number of service frameworks for different, some oriented for different industries or applications. And it's very confusing, I think, for people who are end users in the manufacturing space, and also even for suppliers in the manufacturing space who have to make kind of a long-term commitment to software when they put it into a product. So what I'm asking you folks is, how do you envision that kind of the edge landscape, software landscape, especially for open source? Would somebody like to start with that? Brad, we can't see if you're raising your hand, but does anybody want to start and kind of put their perspective on that?
Yeah, it sounds like I was just volunteered for that. So yeah, when in doubt, I'm raising my hand. I'm all in on these conversations. So here's what I think. I don't think the edge is so new per se, right? I mean, we've had software and computers running in industrial environments and retail environments, on premise for years and years and years. But for me, the excitement is around a chance to reconsider how we deploy the edge. So as opposed to, treating every device like a highly cultivated, a highly curated device that we have to carefully manage patches and understand, whether it's diverged from the golden image or not. We get a chance to bring that cloud mentality where we have fleets of devices that are managed with the same kinds of tools we're managing our cloud devices. That we can quickly re-provision if they fail. We can quickly cluster if we want to cluster. Right? So I think that's the excitement of the edge for me. It's not so much that we're all of a sudden talking about bringing a particular application or workload, to the edge, but it's how we're bringing those applications and workloads to the edge and how we're using our IT departments to more mirror the kinds of activities we do in the cloud with our devices at the edge.
Yeah, and if I, because this is just perfectly, aligning with what I've been thinking for quite some time. To me, edge is the last cloud that we need to build, right? Because, we've built a few public clouds, right? Some people are building, private. And edge is, in a way, the last one that we need to build. And if you look at the edge that way, then, the multitude of projects actually start making sense. Because, again, when you look at the public cloud, you don't really disassemble it into individual projects. You don't really ask, like, what's your storage or whatever, right, solution. It's just there, right? You go to Amazon, you go to Google, and you use, all the services that they give you. Sometimes they even give you competing services, but it's sort of all given to you awesome package that you can consume in a totally software-friendly way, through scalable and elastic APIs. And I feel that that's the only way to look at the edge, right? Edge just becomes yet another cloud.
Anyone else want to jump in on that point? Landscape?
No, I echo Roman and Brad in that aspect. It's just another cloud. You need it to be a cloud. It can't be a single host. Otherwise, you won't have high availability, resiliency, and things like that. And what better way to use that resource, that platform, than APIs are already popular, established, and well used, like Kubernetes. So that's where I'm coming from.
Yeah, and I think when we're looking into the patterns over the last 5 years, how cloud were evolving, especially also on the container side, like having a standardized packaging format and also a standardized API how to deploy. Something similar needs to happen on the edge. Similar what we have now defined as cloud native, we also need to have on the edge, either also called it cloud native or edge native. But we need to have an end-to-end way. I can develop it on my local machine, and then I know I can deploy it into the cloud, and I can deploy the same application to the edge. And I think one of the big challenges on the edge is more the scalability. And I think it's hard to test this. So if we can simulate this easily and with the patterns we have now in the cloud, it's like, okay, then I'm now can use AWS to simulate my edge environment and, for example, test okay, I need to test 10,000 devices, 100,000 devices in a simulated way. And later I know, okay, I can really roll this out to production into my real edge.
Well, Roman mentioned scalable and elastic. And so you talked about simulation of that, of an edge system. When you get to the edge, if you look at the characteristic, and I'm thinking of the edge that I'm familiar with, more industrial, you don't have that. You don't have the scalability and elasticity that you have with the cloud. You usually are much more tightly constrained. by huge factors. So how do you simulate that, or how do you handle that in the development environment?
Well, it's interesting. Yeah, it's interesting you should ask that, but I think it's the software APIs that start to matter. So I'll give you just one example. So Project Eve is basically meant to be this low-level, operating environment, that gives you capabilities of running VMs and containers, right? And it typically gets deployed in the industrial setting on the industrial PCs, IoT gateways, those types of boxes. And you're absolutely right. I mean, if you have one box, it's not like any kind of Elastic Software API will allow you to clone it into 100. But interestingly enough, you can actually deploy Eve itself on one of the public clouds. So then, by the magic of nested virtualization, you basically get this really awesome way of testing your software, in a very scalable way, by basically asking, let's say, Google Clouds, hey, Google Cloud, give me, 50 instances of Eve, because I want to deploy the software in exactly the same fashion. And that's the key, right? You're trying to make sure that the software, to Sebastian's point, that you wrote on your laptop would be infinitely scalable. And you can prove it on the public cloud. And then once you get that proof point, the platform Eve stays exactly the same, regardless of whether you deployed it on the public cloud as an appliance, or you preload it on your virtual, on your physical industrial PC as a, almost like an operating system.
We have a comment in the session chat. It says the issue, though, is that edge, especially in oil and gas, typically have network constraints and are more tightly bound to devices that need to work more autonomously and in a robust fashion, which to robust, probably means high availability and real-time constraints. So is that part of the domain of Eve, or is it not going to be? Or what about the projects that you are working on in open source, and also, Sebastian, maybe in the real world, if you will, or in the project world of the verticals that you work with?
I can quickly cover Eve and let sort of Sebastian and others cover their sort of respective projects. For Eve, what actually made me very excited about starting it with all the rest of the community as an open source project is this unique set of challenges that Eve is expected to tackle, right? And I mean, there's plenty of really good virtualization platforms in the data center, some of them closed source proprietary. VMware comes to mind like a very good example of that. There's obviously open source offerings. But the problem is that they have all been designed to run in the confines of data center, where, for example, networking constraints, like what you just mentioned, just don't apply, right? It's a very well-designed network with top-of-the-rack switches and whatnot, and nobody really cares too much about, that network being flaky. On the edge, it's interesting because you basically get the compute power that is getting pretty close to what you can get in the data center, but that compute power is packaged and given to you in a package that is much closer to mobile. So what Eve is, in a way, it's this unique intersection of requirements. Some of them come from the data center, scalability, security, what have you. But some of them actually come from the mobile. And I guess Android would be the only platform, in the open source that tackle those requirements. Because just like Android, Eve is expected to hop between networks, right? Just like your Android phone can be on an LTE, this minute, on Wi-Fi the next minute, Eve is expected to handle all of that completely seamlessly and not disrupt the user application. So those challenges are actually what's make it exciting.
Okay. It's an interesting observation. Malini, you were talking yesterday about expanding the reach of some of your products outside of the data center. Can you tell us a little more about that and how that relates to this?
VMware has traditionally been in enterprise data centers, and it's a new business proposition to go to very small edges. I don't think we're yet there. Their notion of edge devices still are laptops and phones. Mm-hmm. So their idea now is to move that enterprise space towards slightly more managed devices like cameras on your enterprise offices, whatever. So that'll be still fitting things into a single pane of glass, but it still will be larger edges. And for me, an edge can be like a single water molecule, a snowflake, a water drop. So there's that range of edges. And I think VMware as a company is still going towards slightly larger edges. We're not at the very small edge yet.
But one thing I've seen in talking to end users about their future deployments is they don't really understand. It's kind of an open question to them. They have tended to opt for smaller and smaller, many small systems just on account of the need to have the consequences of failure be limited. So you don't want to have a failure take down more than one machine or more than one line or more than one process unit or whatever it is. So you want to contain the implications of any particular kind of failure. But with these high availability platforms and some of them becoming rugged and industrial in the hardware space, it's not at all clear to people, I think, 5 years from now in industrial manufacturing, what kind of hardware they might be running on. Just,
my take, and this is also my past having worked at Intel, hi Brad, is that hardware is getting cheaper and cheaper. So where you have like a Xeon server or a NUC or a Raspberry Pi, it's easy enough to make your edge hardware affordable. And then issues come up like multi-tenancy. And then if you have a large cluster of machines or even 2-3 machines, you have that edge cloud. So you have that resiliency from it. If you have software like Kubernetes running on it, and let's say there's a process or a container running there to take in all your temperature sensors and another one to check something on your wind turbine, if something fails, it gets relaunched. So there is all that power that you have from high availability resiliency. And so you don't necessarily need to think about your edge node being a single tiny Raspberry Pi type of machine. And that's how I'm thinking of the edge. And you also need like more than one machine just so that you don't have to roll out a truck over there if something crashed or broke down. Mm-hmm. You could do software updates also more easily and things like that, firmware software updates.
Yeah, and I think it's important now when we're designing a new edge that we really not couple again the hardware with the software, so that we really ensure it needs to be decoupled, because to exactly running in 5 years, nobody knows, or you don't want to log into and not log into this vendor stack. Okay, I need to buy hardware, software, and everything from one vendor. I want to be flexibility, and I want to be, for example, using in the future white label boxes, and but getting the software on top of this. And I think that's the big change as well, so that we really can decouple this and getting much more flexibility in the whole architectural stack. Because when we then have defined interfaces, it doesn't matter. It's only software. It's not like, okay, here's a complete box including software and hardware. You're building software and then it's running, and you have clear defined interfaces, similar as we have it in the cloud today. Also, nobody's asking, okay, do I running on a Dell HP, or you get compute on the cloud? What manufacturer? You don't care.
Yeah, kind of building up on what Sebastian is saying, kind of two thoughts come to mind. One is that when we're choosing vendors, we typically want to choose compatibility, not because we want to deploy 2 vendors simultaneously, but because we want the future knowledge that if we have to switch vendors, we can without a tremendous switching cost. And in line with some of the same reasons why the open source projects are so appealing is because you start to build community standards, right? Whether it's explicitly that we're trying to define a standard, or whether it's a de facto standard by mass adoption of a given, we get to have confidence that over time, our enterprise investments in these projects will have lasting value, because they will persist in either in the marketplace or in the open source spectrum. And so if we can take some of the boring aspects out of deploying edge nodes, these low overhead, low profile nodes, the basic connectivity, the basic security of the boot, the basic deployment processes. And we just handle that as an open source project, kind of, call it, the boring overhead of an edge node. Then we can focus instead on the orchestration and how efficiently we deploy our designs, and focus on the different types of software and workloads that we deploy to them. That to me is the benefit out of investing in open source for applications like Edge.
I don't know if Sebastian, maybe I'll throw this out to you. I've certainly done some listening to people in industrial automation space who have exactly that kind of vision of decoupling at that level. And there are certainly ways they could do that, and they see those things kind of coming. Sebastian, have you done that kind of thing in a real world project? Can you give us maybe an example of some of the work that you've done in that as an example?
Yeah, especially on the edge, I think we are still at the beginning of this. But what we can already see, where we're also quite active, is the whole telco and operator industry. And what you're seeing there is like, in the past, they had really like hardware switches. Then they started like having on the switches virtualized running the software, but it still was like heavily decoupled. And what's now going on there is with container native or container network functions to really decouple this underlying hardware from the software, so that you can really have like white label switches and you're running your software on this. And I think on that side there, it's a good blueprint. I mean, it's not sure that this will work out because it's also the question how the vendors are acting in that side. But you see that especially the telco operators are pushing in that direction. And this is also what the feedback we are getting from manufacturing industries, that they would like to go in similar directions, so that they have the capability to more decouple stuff, and not like, we had the discussion before that if you're looking into the fabric, there are thousands of PCs or servers running, and typically then when do they upgrade? 2 times a year, Christmas and Easter or something like this, and then you're only touching the really critical CVE systems where you say, okay, there's I need to fix it, but the rest you never touch a running system. And I think we need to go to continue, or we want to go there also into continuous deployment. You want to develop quickly new features and be able to roll this out. And in worst case, if it's not working, you want to have also the capability to easily roll back and say, okay, we rolled out a new version. It's not working so well. Let's go to the older version.
Yeah, and to me, this is what cloud native means, right? Because people throw this terminology, cloud native, here and there. To me, it's all about, software development ecosystem and how software developers can basically innovate as quickly as possible, on a given problem. And I think, getting Edge into the cloud native software development will unlock a tremendous amount of value by just allowing much more developers to basically bring to bear, their knowledge and their creativity to solve, all these challenges. It's sort of like the same thing that happened to mobile industry when, we created those scalable and, really software developer friendly ecosystems around Android and iOS. All of a sudden we had bajillion of applications, and half of them are like my, flashlight, but, that besides the point, Yeah. But just tremendous amount that sprung around, basically just 2 platforms, right? iOS and Android. And I think that is that market that is still missing in the Edge. I really want every single developer to be able to make money. And I really mean it, like make money the way they make money on the mobile applications. I want them to be able to make money on the Edge the same way.
Yeah, and I think to quickly catch up on this, and I think one of the big benefits then would be also we can really free up resources because we can leveraging same APIs, same frameworks to build it for stuff which is running in the cloud and also for stuff which is running in the edge, and not like, okay, we need to create similar functions which are already solved for one area for another area again and again and again. So we really can then focusing on new innovations, and everyone can share much more the effort, especially if you're talking about open source development.
Okay, well, some of you, Brad and Malini, are both participating in the chat a little bit. Maybe Brad, you could bring us all up to date. I have a lot of trouble multiprocessing, being a little older, and but you were discussing some things in the chat in terms of bridging, I think.
Yeah. Well, I think they actually kind of mirror what we're saying in the window. I mean, they've been inspired by the conversation in the window, on the panel, because when we look at these geographically dispersed, physically difficult places that we want to deploy edge nodes to, I think the question that Obin is asking is, can we really use these same tools that we're talking about for the cloud for these kinds of edge devices where we know that power is low, connectivity is spotty at best, and it's very expensive to roll a truck to patch, right? And so from that basic problem statement, we know software has to be deployed, right? I mean, we're just talking about alternative ways of doing it as opposed to, saying that we can or can't do it. But, my thesis, yeah, indeed, we can still use these same tools that we use for the cloud, albeit we're not going to use them identically. We're not actually going to deploy a local Kubernetes cluster to the edge in the jungle, but we still may use some of those same tools at the cloud on the manageability side, while these very low overhead or low powered edge devices, which are using the same open source projects as a base foundation, are quietly doing their IoT thing in the jungle. And then when they have their satellite coverage for their 5 minutes of uptime, they phone home and they start to pull down their updates, just as you had a live orchestration session, for a very highly connected, high bandwidth environment. It just may take longer, but you get to an eventual consistency. And so these same concepts of infrastructure as code, eventual consistency, container management, I think are just as appropriate for this kind of distributed edge, remotely distributed edge. You just have to think about, publishing that state and then tracking as a campaign, how your fleet is doing, pulling that state and catching up, and then using those same tools to remedy any machines. I mean, this is a version of the Mars rover, right? You deploy and you have to wait, 16 minutes or whatever for the round trip command to get an acknowledgement that it even received your command. So fortunately, the truck roll is a little less expensive than going to Mars, but there's a similar mentality in that kind of that device management. And so, Malini, I think we're on a pretty similar wavelength in your chat response there.
Yes.
Well, could you explain, maybe, I don't know if this would go to Brad or to Roman or to Malini, but explain to, in a way that an industry analyst could understand, why, what is it about Eve that bridges to an orchestrator like Kubernetes? We would like to think of them as being in different kind of layers. How is Eve more than a hypervisor in doing this kind of stuff? What is it that distinguishes it?
I'd like to take a stab at that, right? Because it's right at the heart of where my team is doing quite a bit of investigation. Simply put, I mean, oversimplifying Project Eve and the components that go into Eve, it boots you to an environment that you can launch a container, period, right? Where you start to extend Eve is how you start to connect those orchestration tools or device management protocols. Now, through Project Eve and the backend management and ZEDEDA, you can use, the ZEDEDA Eve nodes, but you're not exclusively required to use the ZEDEDA API. You could use another open source project on the LF Edge is Open Horizon from IBM, which takes kind of a distributed agent-driven view of how you start to pull those containers down to your edge node. You could take a very, direct Kubernetes type style of orchestration on top of Eve, because basically Eve gives you a platform to run that virtual machine, or Eve gives you that platform to run a stack of containers. How you manage those containers is still up for grabs, and there's still room for innovation and competition and all sorts of solution fitting for the different kinds of problems. But Eve itself is this little edge node that can boot, right? Yeah.
That's absolutely right. And I think, Brad, to your point, Eve is really in business of taking care of all those, boring but super important details, right? It's like, how do you do secure boot? How do you establish root of trust? How do you make sure that, really flexible networking is possible? How do you make sure that you can isolate workloads from one another? How can you make sure that you can run real-time workloads? They're still in a container, but they need real-time, characteristics, right? Next to non-real-time workloads. So all of that is, this boring plumbing that people just, data center most of the time take for granted. And it just so happens that on the edge, nobody before Eve has thought about, building an industry-driven, community-managed overall platform to just give you all of that boring infrastructure in one well-tested package. And to your point, let you loose on what do you want to do with those containers. Do you want them to be managed by Kubernetes, or maybe by Docker Swarm, or by something else entirely, Microsoft Azure IoT Edge? I mean, the sky's the limit. But Eve is in business of just making life easier for you. So all you have to care about is actually running these containers, and off you go.
Okay. There's another point that speaks to this broad landscape that we had as a topic, was the collaboration with Intel and Acorn and probably other areas. Can you talk about that? I don't know if that's Brad or whose area that is. Is that Roman or Brad? I would guess.
I can maybe I can start, and Brad can feel on top of that. So Eve in general takes a very interesting approach, compared to sort of true virtualization solutions, right? In that sense, I mean, Eve doesn't position itself as a virtualization product. We just happen to use hypervisors as mechanisms for isolation, right? I mean, to us, at the end of the day, there is no difference between running a process as a Unix process or running process isolated into a domain, right? And in that sense, we love all hypervisors, right? We started a project, with Zen because we had to pick one. And we like Zen still, very much because it's a type 1 hypervisor, which is, very nice in certain respects. But we now support officially KVM, and Acorn is supported, to boot the control domain. But now, there's a few patches coming in, like right at this moment, to actually give Acorn the same level of support that we have for Zen and KVM. And that just goes to show that, again, Eve is in business of hiding all of those details from you. Just to give you like a very geeky example, right? It's like some people came back to us and asked like, hey, why are you guys not using libvirt and virsh? Well, that's because we don't want that complexity to be exposed to the end user. All we want the end user to know is that you can run your container or VM, right? We will build the best possible experience of doing that, on a given piece of hardware. And you don't have to tweak bajillion of knobs, the typical way you do with, like some of those things that are built on top of, libvirt. You just run that stuff. And Acorn came, very, I would say rather recently, from Intel. It's been out there for a couple of years, but, compared to other hypervisors, it's rather recent. But it's sort of in this long family of hypervisors, specifically designed for a particular use case, right? So Acorn really shines, in my view, in the industrial use case, where you need to mix different types of workloads, real-time, non-real-time. Like one of the best, examples of using Acorn is running, Android infotainment system and, some real-time applications on the same piece of silicon. And it's amazing. It's awesome. I mean, we would love even more hypervisors to be added to Eve.
I would say in the industrial space that we can think of obviously many, many use cases like that where we have real-time workloads and non-real-time workloads. Brad, did
I
you
have a
want to-
question
Go
for
ahead.
Roman here, and this is partly my confusion. Sometimes you refer to Eve as a hypervisor, and then here you're talking about Eve connecting to hypervisors such as Acorn, KVM, and Zen. Could you please explain something more about this, how to think about this better?
Absolutely, and I think you coming from VMware would understand it better than anyone else. But hopefully, other people are also familiar with VMware architecture. It's sort of like calling ESXi a hypervisor, right? ESXi, like, yes, it is a hypervisor, but it's also a thing that actually boots, right? It's not just the hypervisor the same way that Zen is just a hypervisor, right? Because it contains all these other bits and pieces that are needed to actually get to a functional, VM on a given hardware, piece of hardware. So even the same sense, it essentially includes, all of these hypervisor implementations, Zen, KVM, Acorn now, but it provides all the other building blocks to make those hypervisors useful. Because by themselves, I mean, hypervisors are actually not all that useful, right? All they can do is essentially run your code. And whenever they need to emulate anything, they actually have to use other pieces of software, like, QEMU. Whenever they need networking, they have to use yet another piece of software, and Eve just packages it all together into essentially something like ESXi's that you can deploy on an and not worry about integration at all.
Thanks.
Busy typing in the side panel there, but Harry, to your question, we're excited to see the various supported hypervisors on Eve, but I think there's other integrations that the ZEDEDA team and Intel are looking at around Eve, and one of them is a secure device onboarding. So it's a similar problem. It's actually going to sound like a recursive conversation, turtles all the way down, because secure device provisioning in the field is a difficult and boring problem. It's boring because nobody asks for it until the end of your project, when they realize they need to find a secure way to deploy your device. And it has to be done. It's table stakes to do it right. But you can't build a company around basic secure onboarding. So it's a perfect ingredient to put into a project like Eve, where we can then rally around another open source project to solve the secure onboarding. And then when you marry that into Eve and Eve deploys, it gets that kind of benefit. And what I'm dancing around here is the idea that you can basically image your systems in a staging facility using a project like SDO. And when you deploy them globally around the field and they connect for their first time, they connect back to a rendezvous server, which lets them say, hey, I'm alive, I'm up to date, transfer ownership to me, now manage me, and you can start then orchestrating that device in the field. I think until now, a lot of people have been building their own solutions for that. And the goal of the SDO team was to try to create the industry accepted solution, multi-party, multi-vendor, Intel and ARM and others are on board with this effort. And now as part of the LF Edge, we're trying to make it an open source, standard, so to speak, for device onboarding. And so I think that's an exciting path to explore for us to figure out how to get SDO as part of Eve.
Well, I would make a comment on that in the industrial automation space, device networking and device onboarding has been a huge pain point for people forever. And it is likely to get better. Most of the reason they have that issue is because they'd never had a real network connecting to any of the devices. They never had a network that would pass IP datagrams, but that's coming along. So there certainly is a potential in that area to solve a chronic problem and difficulty in the industrial space.
I think there was actually a good question in the chat panel about maybe elaborating a little bit on how a Kubernetes solution can build off of Eve. So maybe Sebastian, maybe you can sort of talk from your experience of like what value would Eve bring to somebody like Lodzi?
I think especially on the edge, I think we need to define like how we want to run a Kubernetes cluster. do we really want to have a full-fledged Kubernetes cluster like master and worker on the edge, or is there a possibility also to run masters in the data center and workers on the edge location? And I think this really depends on like how reliable the power connectivity, the network connectivity is. If you really have reliability in this, I think then it's already possible to run like centralize your Kubernetes control plane and only running worker nodes on your edge location. I think it's a little bit more complicated if you don't have reliable connectivity or power, so that the worker node can reboot or die and it's restarted. Because if you then have no connectivity, the question is if the work application is coming up again. And I think there are good opportunities there for Kubernetes to solve this problem. But I think there needs to be some work in progress to be solved. But I think the whole community and especially, I think the good thing is also CNCF and LF Edge is all under the Linux Foundation umbrella. There is good work to work together on that side to solving these problems and building solution which can help all of us to do the next steps.
You know, it is 1 minute past our time, so I think we have to call this to a halt. I really appreciate the comments of all our panelists and their knowledge, and also want to say thank you to the audience for putting in a very interesting chat session, which I could only about 5% follow, but was added very much to the session. So thank you all very much, and there is a general session to follow this, and I hope you enjoyed it.
Thank you for moderating it.
Thank you, Harry.
My pleasure.
Bye.
Bye.
Bye,
Bye.
everyone.
Thanks, Harry.
Thank you. Bye.